Okay, so in this first video here, I need to replace this existing connection that's going on here for this end plate on the rafter to the column and do something completely different. And it's going to look closer to something like this connection that we see here. Now, the details that I see aren't exactly, like in these pictures, aren't exactly going to work in this scenario. So I'm going to have to do the best I can to match the design intent to what I see here. All right, so the first thing I'm going to do is to just kind of get rid of those connections. I'm going to get myself into a 2D view along that grid line too. Now, I need to create the views for the entire building anyway, and this is a nice simple building here. So I'll just come over to my MBS tools, and there is a MBS view creator. So it's this tool here. And for simple buildings like this, where I'm not using project, I'm just using like an MBS job, I can just go ahead and say create views, and it'll create all the views for me around the building, including my rigid frame lines. Now it looks like this is actually kept to be the same frame all the way across. So if I double click on this and look at the properties, this is just like a rigid frame here. It looks like the same sizes all the way across. So this is like a uniform set of rigid frames, like even at the end walls. Now, I needed to know that because I wanted to see if I modify one of these, if I can use the same connection that I manually model and apply that to the rest of the knees on all of the frames in the building. And it looks like I can here. So now that I've got those views created, I'm going to just go ahead and open up my views list, and I'm looking for rigid frame along grid line 2. So rigid frame elevation along 2, I'll open that up. And here we have a nice view right at the center line of those rafters and columns. Now what I can do is I can come in and take a look here, and I need to go ahead and get rid of some of the things that are involved that are already there. And I just want to be careful that I don't delete the slots or something that shouldn't be deleted here. So I'm just carefully doing my window, and I'm making sure that I'm grabbing all of these existing cuts, any welds and parts, and looks like I've removed everything. So then the next step is I'm going to just go ahead and put in some construction lines and start getting the cuts in here before I model my plates and my bolts and my welds. All right, to get started with that, I'll actually come over here to the applications and components, and I'm going to do a search for lines. And there's these construction lines tools, which are pretty cool. They're custom components. So if I click on that beam and click on that column, I can actually get some construction lines around the edges of the material, so that way I can quickly find those intersections. Now that gives me basically this corner point to actually fit or cut the rafter here at the face of the column. So then I'll go to the edit tab for that, and I'll go to fit part end. I'll then click on the beam because again, Tekla's telling me what to do here at the lower left-hand corner. So I'm selecting the part that I'm cutting, and then I can basically pick, right here at the outside face of this column. Let me actually turn my intersection snap on down here so I can go, looks like midpoint's kicking in, or if I want to force it to intersection, I can right click and do that. Then I'll just pick 2 points there. And what will happen is this fitting plane will actually get created. Now I'm going to tile my view so I can look in 3D and in 2D at the same time. And so if I'm like trying to figure out which corner or which side I'm at, I'm actually over here. So that's okay. I'll go ahead and rotate myself around so I can look at that condition there. And what I was showing you is there's that fitting, right? So there's that large fitting plane, which is that cut, and cuts that beam all the way across on its length there. Now, the thickness of this plate is actually 3/8. So I'm going to just move this over 0.375 and let's go ahead and say expand there. Just expanding the view depth of that view. But there we go. That's moving the cut over because I'm going to actually put the end plate on top of that. Now to get an existing end plate's properties, so I don't know your standards fully well, so let's just see what's here. So I can just grab an existing plate as a starting point, and then I could save those settings away. And I kind of did that here as end plate and rafter, just so that way I can make sure that I'm matching exactly what SlideRule did, and I have all the same matching standards here that your cleanup tool does. So I can start with that and save it away, but I've already kind of done that here. So I'm actually going to use the beam command. So SlideRule will do these end plates and stuff as contour plates, but sometimes it's easier to model as a beam. And so I've actually created an SBS end plate settings that are start point and saved away. So I'm actually going to use those. And then what I'll do is I'll just click here on the top of the rafter, and then I'll just go down. And this is going to be right here on the top of that. And so then there is our plate. Now, let's just go ahead and take a look at that. And does that look correct in the model? Looks good. And so then we also need to do the fitting for the column here. And we're going to put in a cap plate on that. And so the cap plate for that is basically going to be from like right there. And then we will go here. I'm just going to start there for now. And if the rotation comes in wrong, like here this shows front, that's no problem. We can just come in here and set this from top to front, modify, and there we go. We can see that the plate is rotated. And then if I just need to center this here, I can just say middle, and there we go. That looks pretty good. It's nice and centered. So I tend to model in 2D and 3D at the same time, so that way I can see and make sure that everything I'm doing in 2D positions and material-wise looks really good in 3D as well. So I'll continue to move on here, and I'll click on this plate, and actually I want the depth of this to go behind, so that way it goes down into the column. That looks really good. Yep, and so we've got that extending across, and I'll probably do the fitting here. So go back to Edit tab, and that's where we do our cuts, and I'll do Fit Part End. I'll pick on the column this time, and I can just pick on 2 points on the underbelly of that plate there, and then it cuts the column back. And there we go, we've got that kind of start point. Now, what I might do is I might actually stretch this a little bit further. So, right now it's 10 3/4-ish. So let's actually just stretch the end of that plate. So I'll just grab that point there, and I'll just move it from there. So I'm going to pick that point as the origin. When I watch this, I'm going to say Control left click and just go ahead and type in 14.0. And let's just see what that gives us. So that gives us a little bit too long of a plate. So that's too far out. So let me actually just kind of bring that back a little bit. Can probably bring that back about 2 inches. And there we go. Now I've just got a nice even rounded number plate, and it's going a little bit beyond there, so that way I can make sure I get that weld. And I can shorten that up as needed, but I wanted you to see kind of how you do that. Now the next thing would be is to go ahead and get the bolts in here. And actually we need to get one more plate, and that'll be the plate here for this end plate on the flanges. So let's go ahead and get that done. Now I'll probably come up here and I'll do points command at any position, and I'll pick this spot right here. And it looks like that'll be basically the center of our plate where we're going to kind of do the bolting from. So here I'll do 3.5 because it shows a 7-inch spacing on the center bolts here. And then I can even just copy this again, and I'll do, let's see, looks like there's 3 inches on the next one, and then 1.5 for the edge distance. So let's see, do I got that there? Yep. So I got, let me undo that. Let's see, what did I get? So I'm going to take that point, let me just say copy, and we'll do 3. There we go, there's that, and then I'll just go up a little bit more, 1.5. I should have just moved my cursor, that's what happened there. And I'll rinse and repeat down here. So I'm going to grab just this point here, and we'll say copy. I'll just go downward 3.5, and then I'll go 3 inches from that point, and then I will go 1.5 inches from there. And that basically represents like my plate and where my bolts and holes are going to be. All right, so I'll go back to steel, and I'll go in here, and I'll just go ahead and use this end plate settings that I've got set here. Probably need to change the prefix of this to whatever the shipped loose plate mark needs to be. I'm not exactly sure what that is, if it's like EP or something like that. So maybe I'll just change that so you can see that that's the loose plate. And I'll go from the top to the bottom here, model in that plate, and then it looks like I just need to kind of rotate some things. So I'll switch this to top and say modify, and then I'll need to go ahead and center this. So I'll say modify, and then looks like the plate material will probably need to shoot maybe to the left or to the right. Let's see, to the left, looks good. So now we've got the positions of that material in, and we're ready to bolt that up. Go up to my bolt command, and here in the properties, what I usually tell people is when they get started with the bolt, always load up standard, because you don't know which properties you had done before on your bolt spacing, your bolt type, if you did a bolt command somewhere else in the model before. So I always say just load up standard to start with, and then let's just change a couple things. We'll do 3/4 inch A325N bolts. Everything looks pretty good here. And then what we'll do is we'll pick the 2 parts that we're going to be bolting together. Now I'm going to be bolting this end plate to this cover plate, so I'll just pick the 2, and then I will middle mouse button. And then what I'm going to do is I'm just going to pick from the top of the plate to the bottom of the plate there, and it should basically put in my first bolt. Now if I see a condition like this, I just need to change the bolt rotation. So I'll come down in here into the properties, scroll down, and I'll switch this from front to say top. And there we go, we can see that that bolt is positioned there. Now, the bolt direction is formed by the first point to the second point. That's basically the X direction in the bolt properties of that bolt group. So what I'm going to do is I'm going to change the edge distance here. There's a DX or direction X offset from the start point, which was my first point up there. And I'll type in 1.5 inches. There's my edge distance. Then for the gauge, since I want to do that perpendicular to my X direction on the bolt, I'll type in 3 in the Y, and there's my gauge on the bolts. Then I have a 3-inch spacing, a 7-inch spacing here, and I can hit modify, and then you can see that. Now, technically though, there's kind of a gotcha that I got to watch out for. These holes are not really going through that material on the column, and it's misleading. So because really I'd only pick these 2 parts up here to do the initial bolting on this particular piece. And so those bolts can't extend down there like that in the same bolt group. So I'll just actually remove that and just say enter. Now what I can do is to get those bolts between the plate and the column, I can go ahead and select the 2 parts here, middle mouse button, and then just reverse my picking order, go from the bottom to the top, and it'll take those edge distances from that start point and then that bolt spacing of 3 inches, and it'll just reverse those bolts going upward. So there you go. That just kind of shows you how you can quickly get those bolts in, and just make sure that you don't run into the gotcha of trying to bolt these 2 parts up here and extending those bolts below, because the holes won't show up in the column flange correctly. All right, so now we've got that bolted together. Let's go ahead and just use the same bolt command, and we'll bolt here the rafter to the column plate. So I'll just go ahead and activate that command. Now, since I've got very similar bolt properties here, I'll probably just start with this, and I don't need to load standard because I know the settings that I just changed. So what I'll do is I'll click on the, whoops, wrong thing here. We're going to bolt the rafter or the beam there to that plate, and then I'll just middle mouse button. And let's just say that I pick here as the start point, and then I'll go to here as my end point. And it looks like I just got to change the rotation properties again. So I'll change this from top to front. Say modify, and you can see that the bolts are centered there in 3D. And then what we probably want for the edge distance to our first bolt is, instead of 1.5 inches, I'll change this to 3 inches. And then what I can do is I can kind of mess around with this setting here to get it close to the 3 or 3.5 that I want probably from that edge. And so let me just actually measure this here, because I'm just trying to keep the plate nice and simple. 4 inches. Okay, so that'll make it asymmetrical, so it's very clear to see which way that in the shop that plate needs to be kind of oriented on that column. So that looks like a good starting point there. I've got all my bolts in, and these are field bolts here. So if I click on those and scroll up to the top, this is set to site, so I know that those are field bolts, and that all of this is a field bolted connection, and this will be a loose plate here that's just shipped loose and then field bolted to the column and the rafter. The last thing I need to do is go ahead and do the welding, and then I'm going to make a custom component. I actually forgot the stiffeners, so I'm going to go ahead and do that first. So what I'll do is I'll zoom in here, and I can see where the construction lines are intersecting the top flange of the beam, and that looks like where the stiffener should start from. And so to do that, what I'll do is I'm actually going to cut a view. So I'm just going to go to view, and then I'll go to new view using 2 points. And I'm actually going to use some temporary view settings here. So I'll just say load. Yeah, there we go. And they're actually loaded by default. So I'll apply OK. And then really what I'm going to do is I'm going to find this intersection. So I'm going to go to that intersection right there where the construction line hits the top flange. And then I'll just go perpendicular here. So I can right click and say perpendicular to just shoot straight up. And then now that's my view. Now, when you cut that view, it's going to cut it of the entire model, so it gets a little bit hard to see everything that's going on there. So when I select on some pieces, trying to find that's the actual rafter and area that we're focused on, right? So let me actually just grab this beam, and then I can say fit work area in selected views, and that'll just kind of change the work area so I know exactly where I'm at in that view. The other thing is there's a lot of other stuff in my way here, so it's kind of noise and congestion. So I'll just decrease my view depth to say 1 inch. Modify, and there we go. Now what I'm going to do is I'm going to come up to the steel menu, and I'm just going to choose the plate command, and I think I've got some save settings here for the stiffener, and there we go. So that's just got all those properties, and that just saves you a lot of time having good save standards, so I don't have to type all that stuff in. And now what I'm doing is I'm just using this contour plate to basically put in my stiffener. Middle mouse button, once I've got that contour picked, then I can just, come in here and click on the corner points and set this to 0.5 if I want to have basically my corner clips there. So I'm going to just say 0.5. But I just noticed this is actually not a full depth stiffener on the top. So what we'll do is we'll just grab this, and maybe I'll just move this down here. So let me just see how tall this is. It's 13.08. So I'm just going to go ahead and make this maybe 12 inches long. So I'll do 12. Not sure exactly what the criteria is for the length and keeping that away from the top flange. but I'll just make it a simple length there. And now I'll grab that corner only down here, and I'll just change this to 0.5 on the X and the Y. And then now you can see that we've got that corner clip set. Okay, so the next thing is that maybe I want to do a mirror of this plate, from one side to the other. But I need to see how this is actually positioned. Let me just see if the material thickness is positioned the way I want. So it looks like it's not. It's it's centered right here, and maybe I want this to be at behind. So I'll say modify, and now the material shoots downward closer to the actual inside of that flange there. All right, now what I'm going to do is I'm going to do a polygon weld. So we'll come up here to weld, and we'll say create polygon weld, and I'm going to weld that between this part and then that plate. And I can pick my 2 points, but let's just look at the size here. It looks like near side wants a 3/16, and then for this one, see, so the main part looks like on the web we only need it on one side, so I'll pick 2 points. Then down here we need a double-sided weld, so I'll say 0.1875, and then I will pick my beam, my plate, pick the 2 points there, middle mouse button, and then there we go. So when I look at this, there's the near side, far side weld there, and then only the single side weld for the top of the stiffener. Now what I'm going to do is I'm going to do the mirror. So I want to take this, and I'm going to change my work plane here real quick. So I'm going to go to View, I'll say Work Plane, and I'll say Parallel to View Plane. I'm going to pick in this view here, and now the XY changes to that plane, so that way I can quickly do this mirror. So I'll do Copy Special Mirror. I'll pick 2 points at the center of that beam there, say Copy, and there we go. There's the copy of my plate. So now I have that stiffener on the near side and the far side. I'm all done with that view. And let's say I want to change my work plane back to global. So to do that, I just come down here to the lower left-hand corner, switch that to model origin, and then I'm good to go. All right, so I've got those 2 stiffeners added, and now I need to go ahead and do the rest of the welds. Now, when I do the welds here, I'm going to be doing them thinking about this being done on an AGT Beammaster or the robotic welding machine. And so I'm not going to want to actually apply polygon welds here in my 2D view because it'll be modeling them at the center line of the rafter and the column, which will not allow the the welds to identify the correct surfaces. So I'm actually going to close this down, and I'm just going to do all of this in 3D. Now, what I could do is I could, just to prevent myself from fighting all of the purlins and stuff all the time, what I could do is I could actually just grab some of the purlins and right-click and say hide. That's one thing I could do. What I can also do is actually just window around the steel up here at the top involved with my connection, right-click and say fit work area in selected views, and now it just decreases that. So if I redraw, we do see some purlins, but the rest of the roof and the rest of the job's not in my way when I'm trying to rotate around things here. Another way you can do this is if I fit the work area to the entire model, what you can do is actually just window around some of the steel and right-click and say create view. So there's create view, and then there's this 3D view. So when you have multiple parts selected, you can create that 3D view, and now you just have a dedicated 3D view that's just zoomed into this particular connection. And then you still have your main 3D view here, which is fit to the entire model. So just something to keep in mind when you're trying to do something intentionally in 3D, but you need to get the noise or the congestion out. That's a couple of strategies of how you can do that. Okay, so it looks like in this new 3D view that I created, the welds were turned off by default. So how do I get those on? Well, sometimes I'm going to use this floaty toolbar or the contextual toolbar here, just because it's a little bit easier for me to do that. And if you don't see that pop up, you may have it turned off. But if you click on a part and then click on a view, you should see that that box show up here. So I'm going to first show up how to do this here. Like right now, I can see that the welds are off. And let's just say that I want to see everything in this 3D view. So I'm just going to click the all button at the top on both of these, and it should turn all of the eyeballs where everything is visible in the model, including fittings, welds, cuts, bolts, everything, and then even points. All right, so we've got that set. The other way to do this would be to double click on the background, which opens up the view properties, go to the display button, and then you can control that visibility setting up here at the top. So these checkboxes turn everything on or off. So when they're unchecked, everything would be off or on. We want all of these checked, and we would say modify and then just cancel. And now we have everything visible for us to work with. All right, let's start with the end plate welds here to the actual rafter. So what I'll do is I'll go to the steel menu, I'll go to the weld command, and I'm going to go to the drop down here and do create polygon weld. Now, what I'm going to switch this to is it looks like I need to do a 1/4 inch near side, far side weld for the web. So I'll just change those here. And let's actually just change that number, 0.25. There we go, 0.25. All right, so we've got those two sizes in there. And then I'm going to pick the rafter and then the end plate. And then it basically says pick the 2 points to apply your weld. So this is why I'm doing this in 3D, so I can get right at the contact surface between the rafter and the end plate. So I picked those 2 points and middle mouse button to close out that polygon weld. Now, there's my weld there, and you'll see that it's actually drawn on the near side and the far side. So it looks really good. All right, then it looks like I've got a 3/8 weld that's single-sided. So let's just get rid of those, and we'll say 0.375 for that size there. And what we'll do next for that is we'll come back into the create polygon weld command. We'll see that those settings have stuck there. Again, I'll pick the beam, then I'll pick my end plates. And now I need to actually see inside of that weld to find that corner point. So if I just kind of rotate, you'll see that there's that inside corner there. So I'll pick there to the outside, middle mouse button, and then there's my weld. And then really you just kind of rinse and repeat this process. Right? So I'm going to do the weld up here. Did Control-2 to get into transparent. If I'm in transparent, I got to click near the edge of the material. So I'll click on that beam, then the end plate. And then now I've got that corner point. So that's 0.1, 0.2, middle mouse button. And again, you just rotate around and repeat the process. So here's my next weld. Pick on the beam, pick on my plate. And then I can just kind of come in here, make sure I find the right corners. I'll pick there to there, middle mouse button. And there we go. And then the last weld is down here at the bottom. So I'll pick my beam and I will pick my plates. And then I'll just find that corner right there. There's 0.1 and then 0.2, middle mouse button. And now I have all my welds done. Now that took a little bit of extra time. You could have done simple welds as well. But I just did these welds here so I could control exactly which side and the length of the welds that I need specifically here for the robotic welding machine. Okay, so now I'll do this weld here on the column to the cap plate, and we'll go to Weld, create polygon weld. I'll pick on my column. Then I'll pick on my cap plate. And here we can see that we actually need to change a couple of the sizes. So I'll do 0.25 and I will do fillet and then 0.25. Okay, so I'm going to get that near side, far side. I will come in here and click right at that corner and then click up here at that corner, middle mouse button. And there is that near side, far side weld created. Now, just to make sure, I might interrupt there and Control-2. And I just want to make sure that both the welds are actually drawn and shown. And it looks like they are, so that looks good. So then I'll just say okay there. Now we got another near side, far side weld that we have to deal with, but we've got to watch out and see how this is going to actually work out here. Because if I come in and do this weld and say create polygon weld, I'll click here and then click the cap plate. And let's say that I even use this outside here to kind of put this in. So I'll pick those 2 points, middle mouse button. Now what I got to watch out for is that if I try to do that double side, you'll see that it's not actually working here. And it's probably because of the web, so I probably can't accomplish that. So what I'm going to do is I'm actually just going to switch this back to 0 like that, and that just gives me that near side weld. And then for the far side, again, for the machine, I'm doing it this specific way. I'm going to say create polygon weld. I'll pick on my part here, my column, then I'll pick on my plate. And then there's my inside corner there on the flange, middle mouse button, and then there's that weld. So you'll see that I'm actually doing separate welds. That weld just goes partially to the web, and then that weld goes all the way across. And then just on the other side here, what I'll do is I'll weld in there just like I did on the other side. And so this is where you got to be careful in 3D because you see a lot of stuff going on here. So sometimes it's actually easier to do solid. Select that web weld and just say hide, so that way it's not in your way. Then you can come back to the polygon weld and then pick your 2 parts. And then we'll pick those inside corners where it's nice and easy to see because we hid the web weld. And then there we go. And then just one more weld to do down there at the bottom, but that basically shows you that process. Now, once I think I have all of the connection done and welded up, I'm going to check the assemblies are correct. So I'm going to select on this, right click and say Inquire Assembly. And that's actually going to show me all of the pieces in yellow that are sub-attached or submaterial parts attached to that main part, which is orange. And in this case of hot rolled rafters and columns, I do want the rafter to be the main part. And then on the column, if I click on that and say Inquire Assembly here, we can see that we want the cap plate to be submaterial and the main shaft or the main part to be the column piece there. So there we go. That looks pretty good. And you'll see that this end plate here, or this cover plate, if we say Inquire Assembly, that is its own main part and just a loose assembly because those are being field bolted to the column and to the rafter. Okay, so now it's time to make a custom component of this so I can apply this same connection and all this work I did to all the other knees on the job. So what I'm going to do is I'm going to start picking my objects, and I'm going to carefully go through and do that. So I've got one set of bolts down here, the cover plate. I've got this fitting for the column. I've got the fitting for the rafter. And I'll tell you, people usually forget this, right? They forget to grab those fittings. They just try to window around the connection and grab stuff, but I'm very methodically going through, making sure I'm grabbing everything that logically makes sense. Now I also want this end plate on the rafter, the cap plate on the columns. I'll grab those bolts. I'll grab that set of bolts. So we'll grab both the sets of the stiffeners here, so near side, far side. And then I need to start going ahead and going through and clicking on my welds. So I've got that weld for the stiffener at the web. I've got that weld there. I've got this weld here. And then I'm just going through and making sure that I'm grabbing everything. So there's that double-sided there. We'll grab that one there. Looks like I missed these welds in the column, or sorry, in the rafter. And then we'll grab those. I'm just carefully going through and looking. Now I could have windowed, but I'm just doing this on purpose to make sure that I really am grabbing everything that logically makes sense. So I've got this side here. Just need to grab these two welds, it looks like. Okay. Then I need to grab these here. And then I think I'm in good shape. I think I've got everything. Yeah, so there's the top and the bottom welds. Got that near side, far side weld there because I grabbed that from before. Okay, so I think I've got everything that I logically need here in order to make this custom component. So then what we'll do is we'll go to the Applications Components panel. I'll clear out this search here. And in the hamburger button, or the pancake button, I call it, up here at the upper right, we can go ahead and say Define Custom Component. Now what I'm going to do is I'm just going to call this, this is the customer name, so SBS, and then I'll just say underscore, and I'll just call this knee connection. Now, we're just going to keep it simple. This is generic. It's just for this job, so I'm not going to worry about messing around with any of these other settings on the other tabs. And we'll just say next here. I've got all the component objects, which means the objects that are going to be created by this custom component and the connection. And I've got those selected, so I'll say next. The main part will be the column. Next, secondary part will be the rafter or the beam there. And then I'll just say finish. And now that custom component has been applied. So if I select on the green cone and delete that out, and then let's just redraw here so that way everything gets wiped out. And then let's even get rid of these construction line components now. So that way we're just kind of seeing the raw steel. Looks like, yeah, hey, the points were still left behind. We can actually get rid of those too. But if I delete everything out, I should just basically see the raw steel. And that's good. That means that I probably caught everything in my component. So I'm going to do a search for SBS. There's my SBS knee connection. And then I can pick on the column, once I single click to activate this, and then pick on my rafter, and voila, there we see that full connection and everything applied. And I'm just looking through here to make sure all the welds and everything came across. This looks pretty darn good. I think I got everything because that's underneath there, near side, far side. So it looks good. It looks like I've got everything in there. So the next step would be to go through, delete all of the other connections, like in all the materials at all the other columns, and then just basically apply this custom component. Now, the safe way to do this, rather than trying to do that in 3D and just kind of grabbing and making sure I only get the right stuff, it might make more sense to actually come back in here to my views. I'll go into my view list. I'll open up a rigid frame along grid line 2 again, and then we can kind of see that there's the component version where everything's all nice and clean. But over here, we need to go ahead and fix this. So I'm just going to window, around the steel that needs to be deleted. So here are these holes, and then basically this cap plate needs to go. We need to get rid of these cuts, and there's that cut on the end there. Get rid of that, and it looks like I'm clean. So now I can just go ahead and activate the component and pick my two pieces, and then there we go. So just the advantage of being in the 2D view versus 3D is that I can actually kind of do better window selections, like windowing around just the things I want and making sure that I'm not accidentally deleting things that I don't want to be deleting. But there you go. See, the connection gets applied. It worked on the reverse side of the building because the geometry is symmetrical in how the rafter and the column are framing together on this side of the building. And so everything gets applied and looks good here as well. Okay, so now I've got this kind of reversed Purlin eave, and it looks like it's the same size right now as the one up here. Yep, so those are the same size. So if I'm going to use this, then basically I need to get those bolts down there. So what I'll do is I'll grab these 2 bolts. So I windowed right to left, so I grabbed both of the bolts here. You can see the quantity of 2 at the lower right. And then I'm just going to say copy from that point there. And I can see it's 1.2502 from... Let's see, where did I measure from? From that corner. Okay, so now I know that I can come down here and I can just say Control left click and then hover my mouse 1.2502, and then there those 2 bolts copy across, and they are positioned exactly that same distance up there. And there we go, looks good. So then again, I can make a custom component of that and apply those between basically the purlins that are there and the rafters, or I could just copy that from frame to frame really quickly. Okay, so the final test here is to make sure that the piece marking has remained consistent after we did this manual modification. We're going to come up to Drawings and Reports, Perform Numbering, and do a Numbering Modified. And that will go through and evaluate all the parts and assemblies in the model and assign the piece marks and quantities. Now down here on the bottom, I'm going to change my selection to Select Assemblies. And what that'll allow me to do is click on this assembly, and then I can see Properties. But let's say that we come up here to the Quick Inquire at the upper right, so that way we can just see the piece mark without having to inquire individually. So that's ER2, ER2, and ER2. These are ER1s, ER1s, and ER1s. That's great. Now people are going to ask me, well, why aren't they both ER1s on each side? Well, clearly here because there's holes on this caused by this basically like this jam column or whatever here, and that's putting holes on those set of rafters, and that's why they're different. Now let's look at the columns. So we've got EC3, 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 and then we've got over here EC2, EC2, and EC2. These are different here because on one wall we have basically looks like rod bracing, and we've got those slots in there, and then on the other side the slots are not there, so that's why the columns are different. But what does matter is that all of the columns along that line and the rafters along each line here are consistent on each side of the building. And so that means that our custom component and all the modeling we did here was repeated correctly on all of the different corners, and we didn't cause any piece marks to be different, which sometimes happens when you manually model like something over and over and over again, like in different locations. So that was one of the other benefits of using the custom component, is that I'm guaranteed that as long as the framing geometry of the rafter and the column are the same, that all of the modeling that I did here is going to be applied in exactly the same way, from this knee to this knee to this knee, etc., which helps in making sure that we get the same piece marks when we run numbering.